Okay, we're a few minutes from starting. For those of you early birds, any questions or concerns? Anything coming up for you? Everything copacetic.
Sir, actually, I got a question. Can you
Sure.
hear me? I was going through the reading, and there's some stuff that's in the sections that we've been assigned to read that you haven't lectured on. That like if we're totally getting our mind blown on it, should we just kind of chill and you're gonna get to it at some point?
Um, Maybe. Is there anything in particular that you need clarification on?
I'd have to pull it back up. I'll probably end up shooting you an email, kind of try and get some clarification on some stuff that's might just be just going over my head now because I don't have the big picture yet.
Yeah, yeah, you raise a good point. The thing is with modern languages like Java, it's substantially bigger than they used to be, and it seems to be getting bigger all the time. I mean, the irony is that when Java first came out in the mid 90s, in the last century, uh, its selling point was that it was compared to other languages at the time, like C++, it was it was put forth as being kind of much small and simple and easy to learn. And actually, compared to C++, that was very true at the time. Over time, as it gained substantial mind share to the point where it's eclipsed C++ as the dominant object-oriented language, it's it's just been subject to the same kind of feature creep that you see in applications from office-like applications to operating systems and languages too. So it's there's a lot of stuff there. Even when you kind of strip a lot of that away, and again, we're just really going to uh, be covering the basics of the language in this course. Um, Even with that, when there are features that are important for large-scale applications, such as this strong typing and this package namespace stuff that's going on, and encapsulation that we're going to explore a little bit today. These all just sort of put a lot of they just put a lot of stuff on the table. So um, the things that I specifically talk about are ones that I consider to be a little bit more important. I'm not going to talk to literally everything, but I think that everything that the book does talk about is something that is useful to know. So, if there's something that I haven't explicitly covered, and you're not sure what it was getting at or what the story was, there are two possibilities. One is that it's something that really needs to be explained and addressed, and the other that it's something which is important and will be addressed at some point, but maybe not just now. As you've seen, just to kind of get things going, just to write that Hello World program involved a fair amount of work, a fair amount of effort, a little bit more than in some of the other, simpler languages like the scripting languages. Um, and the reason for that is because there's these features that add all this stuff at the beginning, um, turn out to be important. Why are they important? Not because pointy head academics like myself thought they were, but through the experience of people, writing program after program, developing application after application. A lot of these principles are ones that that turned out to be extremely valuable and important, that didn't exist before. I mean, my my first computer language was Fortran, You can hear about that in museums. I don't know if you've even heard about what Fortran is, but it was, and I wrote the programs using punch cards, which we fed into this noisy computer and waited about an hour to get our printout, only to discover that we had an error on line 5. And then, we'd sort of fix the 5th card, run it through again, wait an hour, and discover that there was an error on line 10. So life is a little bit different now. So I don't know if I've answered your question in there. You just kind of got me onto a little bit of a rant. But again, if you read something and I'm not addressing it and you feel that it's confusing things, then I'd be happy to address it. I'm looking at the chat here. Tell us I say it. Yeah, I'm okay. Regarding terminology, I mean, there are kind of 2 levels of this. One is that concepts that we keep that keep coming up again and again. Hopefully, those terms kind of get into, just kind of get absorbed. For example, important terms in Java that we started talking about yesterday are the notion of access. So what's the access? Private, public, protected, and none. Okay, so those are 3 keywords. They're important words, and because they keep coming up. In other words, the concept of access is an important one. Knowing the difference between private and public access is important, and for this course, knowing that protected access and access with no modifier are ones that we do not use. We will not be using here. Okay, so if you remember that, then hopefully that shouldn't be too much to remember. So I'm not big on memorizing a lot of terminology. The terminology that's important is that are the concepts and the words that keep coming up through use that just naturally get absorbed. I mean, I can't memorize words to save my life, but if I'm using a concept and using a word and using key phrases repeatedly, then I just kind of absorb them. My hope is that that's the same here. So, and the thing is when, like if I'm asking a question on a quiz, for example, I mean, I need to use terminology. I need to use some kind of language. So, in other words, I'm not interested in quizzing you on knowing what the terminology is, but in the process of sort of addressing concepts, terminology has to be used. Does that, hopefully that addresses that comment. Architecture of the language. Okay, so when the architecture of the language, okay. By architecture of the language, they were perhaps talking about the difference between the compiler and the virtual machine and bytecodes and stuff like that. Is that what that comment was about?
Yes, sir. And like we're I'm probably using the wrong terms, but where we
No, that's fine.
type things, because we'll go from one page to the one IDE page to the next within NetBeans, and sometimes I get confused. I guess I like to sort of try to type out my notes as I'm reading, so I'm more actively reading. If you had any guidance before the next lesson as to what we should focus on in the reading, I'd appreciate it, because I can sort of delve into that a little.
Oh, okay. All right. Oh, no, that's good feedback. So in other words, for the next bunch of reading, you'd like me to give a little bit of guidance on what to focus on and what might not be quite so critical.
Yeah, I can sort of sketch it out and ponder on it a little more. I'm one of the slower ones in the class, so.
Okay, yeah, no, I will do that. Well, I'll attempt to do that. So, I mean, one of the difficulties is, and I think the one of the challenges for a course like this as a second language is that the beginning books are just too beginning. And when I research books on what to use, all of the beginning Java texts assume that you are a complete newbie at programming. And the problem with that is that it just addresses it, not only that it addresses it at too low a level for what our purposes are here, but they also teach extremely bad practices. And the problem with teaching bad practices in the beginning, just because it's brand new, I mean, there's a good reason for that, because if this were your first programming language, you were still trying to figure out what the heck is a variable and what's an expression, then all this additional stuff would get in the way of that. All the things necessary just to get a running program would be confusing things, and it would interfere with your ability to kind of learn the important things. And so they take shortcuts, and in taking shortcuts, they teach bad practices, such as allowing public instance variables. This is one, if there's one thing that you know that I have an issue with, well, it's not just me, but having public instance variables is a mortal sin. I mean, there are venial sins in programming. Having public instance variables is a mortal sin when it comes to object-oriented programming. And unfortunately, in the very beginning books, they do that just to make it easier to get started. So you know, the language is a little bit more complex. I mean, as far as understanding the architecture, I mean, we could spend the whole quarter just kind of delving into how it's all organized. That wouldn't do you any good. What the objective here is to put this language into your toolkit, because it's in my view, the most powerful programming tool that there is. I mean, I know dozens of computer languages. I've programmed extensively in many of them. And for me, if I encounter a programming problem, then Java is my go-to language. You know, and it's not because it's the only one that I know. I mean, it's because I know many languages, and Java is the one that gets the job done. I mean, I don't know if I've shared this. One of the projects I'm currently working on for NAVSUP involves taking a program that they had that was written in Visual Basic and converting it into Java so that they can incorporate it into their readiness suite. They had a working program that worked perfectly fine. It was written in Visual Basic. You know, it was a very nicely written program. I mean, I honestly thought they were a little crazy at first, because they had a perfectly working program, but the problem was that it would not scale up to the extent that they needed it to for this suite of tools that they had, and for that they required Java. So they brought me on board to do that. So I mean, all of this is to say that there's a reason for the pain, I guess, and I try not to. I'll try not to inflict too much of that. So, okay, but I appreciate this. I appreciate this feedback. Please, you know, as we go along, whenever any of this stuff comes up, please let me know. I will do my best to try to respond to whatever helps you get. Again, my objective is to get this into your toolkit. Okay, so with that, we're ready to begin. Okay, on the docket for today is the first piece is going to be a major review. Again, because this is your second or greater language, you've all dealt with variables, and you've all dealt with operators. So just to make sure that all of that is more or less on board, I'm going to go through what the Java operators are. At the margins, there are often some little differences between languages about exactly how they work. But for the most part, operators are kind of the same. There are some gotchas when you move to a strongly typed language from a loosely typed language. And I'll try to point out the little gotcha, the biggest gotcha on that. And then we talked about arrays yesterday, and starting next week, I'm going to actually have you work with arrays in a computer assignment. And what I wanted to demonstrate is what I call encapsulation breach. Now you're asking about keyword encapsulation. That's another term that, again, I'm not interested in you remembering the term, but as a term, what it means is that all objects encapsulate their data, and what their data are. Their data. Data is a plural. It would be datum is, data are. The data are these instance variables that we declare to be private. And declaring them to be private is what is the first wall of encapsulation. But there are times when you need to allow other objects to kind of see what they are. We saw that with the light object, where we had these two so-called getter methods, where any object could see whether a light was on or not, and it could see what level it was. And there was a method that allowed that. Now, there was no encapsulation issue with that, because it was a primitive. And as a primitive, you couldn't do anything that would affect the encapsulation. However, when we're dealing with objects such as arrays, and arrays are objects, there is an encapsulation, a little gotcha that needs to be dealt with, and I'll demonstrate that. And then finally, I want to just show you something about nested loops. We'll get that. Okay. So the main thing is to be able to use numeric operators and Boolean operators. Those are the main two that we have here. Okay, so here's some guidance as far as the book goes. At some point, the book was talking about bitwise operators. Are you familiar with bitwise operators? When I say that, does that ring a bell or anything? I'm getting 1,000-yard stares here, so yeah.
Sorry, again, it was something that was in the reading, but I don't know if the concept has really landed yet.
Yeah, yeah. Now, as a concept, you can put that aside, because what bitwise operators are, I mean, and here's where it fits into the programming context. Object-oriented languages such as Java are high level, and at the high level, you want to deal with with things at an abstract level. What bitwise operators are about is, as you know, every computer word, it consists of a bunch of bits. So we're all on 64-bit platforms now. So every word consists of 64 of these 0-1 bits. What the bitwise operators are things that directly impact those bits. But here's the problem. The problem is that is an inappropriate level of abstraction if you're programming in Java. If you're working with bits, and then there are situations where you may want to do that, then Java is not really the appropriate language to do that. So even though Java provides that capability, it is not something which you have any business using. In other words, a low-level language like C, for example, is much more suited if you're using bitwise things. So, okay, so in terms of guidance, all the stuff on bitwise operators, you can forget. or don't consciously forget, but you're not responsible for any of the bitwise stuff. Okay. So, but numeric operators, they're important. Boolean operators, they're important too. Again, that's a high level type of thing. And then to identify this encapsulation breach, and that's again, the don't worry about the term so much, but you'll see what the issue, hopefully see what the issue is. Oops. Okay, so these are fairly familiar. These should be familiar. So arithmetic operators. So we have plus, minus, times is a little star here. Division. Okay, so this is one of the gotchas here. You want to watch out for integer division. I'll show you an example of that. Oops. Well, come on, what are you doing here? Okay. Actually, here okay, in Java, supposing I want to evaluate this expression in Java, do you know what that would be equal to? Anybody?
0 point whatever. It'd be not a float. It'd be
No. That's what this will be 0. Okay, let's sort of talk through this. And this is where the strongly typed language differs from a loosely typed language. In a loosely typed language, a number is just a number. And so in JavaScript, in Python, in any of the non-typed languages, you would get the digital approximation to this. You're correct in that. In a strongly typed language, if I take an integer and divide by an integer, the result has to be an integer. Let me say that again, because that's, if you remember that, then that'll help, clear up, it'll help guide you on this. If I have operators on integers, the result is going to be an integer. It has to be. And if I take an integer, what is the only question then is, what integer would this represent? So this could be, they could have made it a 1 or a 0. But those are the only two choices. Those are the only two integers that this expression could possibly be. Okay, do you see that? So when I operate on a type, then the result is the same type. So if I multiply two integers, I get an integer. If I divide two integers, I get an integer. And the only question is, what integer do I get? And this is a complete so that's a logical consequence of the strong typing. The only question is, should it round or truncate? And it's kind of an arbitrary choice, but the answer is truncate. And this goes, back to all strong type languages have done the same thing. And originally it was for efficiency. In other words, it is much quicker to truncate than to round. Okay, this is something which I think last year, something like this actually inadvertently bit me. So this is something that's going to be out there. This is something that may bite you at some point. Okay, so that's why I say watch out for integer division. So just be whenever you're dividing things, you have to be very mindful of this possibility. Okay, what are you familiar with this operator, the percent?
If we do integer division, will it always round down?
Yes, Well, it doesn't round, it truncates. So what it does is it finds the lowest in it, yeah, it always truncates. The thing is that you should never do this, right? The thing is that it's easy, it's just all too easy to do. If you do this, then it's clear that your intent is to get this. Your intent here is to get like the closest approximation to 2/3 that you can. That's your intent. But what you're going to get is this. So it's there's a way out of this, okay? And we'll talk about that. I mean, that's just put that aside for now. Okay, so the percent operator, the modulo operator, are you familiar with that? Yes, no, okay, yeah. So now, unlike other languages, for whatever reason, simplicity, there is no exponentiation operator. In some languages, there's like the double star, which exponentiates. Java doesn't have it. Okay, and then for every one of these operators, you can combine it with an assignment. Are you familiar with this construct as well? So if I have like x times equals 3, then that will take the value of x and multiply it by 3. It's the same as saying x is equal to 3 times x. These are the same. And it's just a shorthand way of doing that. It can be convenient, not required. I kind of go back and forth on this. It's a purely stylistic thing, so I'm not, whichever you prefer. I've come to actually prefer this a little bit because this just makes my intention clear. And this is something I'm going to start, you'll start hearing from me a lot. One of the most important things in writing a program and also reading a program is to make the intent of the programmer as clear as possible. In other words, I want to make what it is I'm trying to do as a programmer. What am I trying to do? I want to make that as clear as possible. And so what that has led me to is a style which is a little bit more verbose than some of the fancy programmers, the fancy ass programmers that like to make everything really concise and tight and clever. So clever programmers tend to write code that's write only. In other words, it is so clever that nobody can understand what the heck it's doing. Okay, so now this is it in miniature a little bit. Now this is not such a big deal. So this is perfectly fine. This makes my intent absolutely clear. In this, I may have actually sort of accidentally fat-fingered a star in here. Maybe this wasn't my intent. Maybe I intended to set x actually equal to 3, but fat-fingered a star in and then somehow left it in. Here, my intent is absolutely clear that I want to multiply by 3. So again, you're going to hear that phrase from me a lot, programmer intent. What is your intent? Okay. Other unary operators, so basically, plus x, minus x, you can actually put those in. Not a lot of use for this. Sometimes you might want to take a value and flip it. The book talks about operator precedence. What I encourage you to do is not worry about that quite so much, but always use parentheses for clarity. Again, this is programmer intent. If I rely on operator precedence to determine the outcome of my expression, then my intent may not be so clear. In other words, if I have, x plus y times 3, Okay. All right, so perfectly legal. So what is the and you should all know the precedents here. So how would this be evaluated? Would I add X and Y and then multiply it by 3? Or would I multiply
No.
Y by 3 and then add it to X?
It should be
Y times
3y.
3 plus X.
Yeah, so I would do this first and then multiply that. Why? Because this operator has higher precedence. But this is extremely bad form. What I should do is this. Because this makes it clear what my intent is. In other words, in any arithmetic expression, never rely on precedence. Always put parentheses to make it absolutely clear. Even in this case, this will have exactly the same answer. But if I'm reading this, if I'm somebody else and I'm examining this code and saying, what did this guy want to do? What he wanted to do was this. What did he want to do if the parentheses are missing? There's some uncertainty. Okay, when C came out, they had this sort of plus and minus things, and they were absolutely enthralled with it. And this has turned out to be actually not such great a thing. There is only one context in which I will allow you to use these operators, and that is in a for loop. That's the only context in which that is a useful thing. Do you all know what this does, right? Do you know the difference between this and this?
No.
Anybody?
It's the same thing.
It's same.
Same thing.
Does anybody know?
The first one's going to take y and add your increment to it, and the other one is going to take y as your increment.
No. Okay.
Are they both the same thing? They both do the exact same thing.
They both do the same thing. However, what is the value? Okay, so let's. What's the difference between these? The difference is that the value of this expression, the value of the expression is actually the old value, whereas the value of this expression is the new value. So they both have the same impact on y, but if you put them into an expression, they act differently. And that's why they should only be used in for loops, never in an expression. Okay, so now Boolean operators. So now Boolean operators, these work on numbers. So X bigger than Y, that's true if X is bigger than Y, it's false if X is not bigger than Y. And less than, similarly, less than or equal to, greater than or equal to, equals. Now, JavaScript has an additional one where they have 3 equals. Okay, Java only has 2, so that's, so equals means they're exactly the same. However, you should not use this for doubles. Exclamation. In other words, you should never try to express equality for 2 double values. Do you know why?
Sure. What is a double?
Double is a floating point. So, so a double That's going to be a double. And it's called double because this this value is represented by two words. It's distinguished from float. That, remember the list of primitives, and the two floating point types are double and float. Float is single precision. It uses a single word to represent the number. And if you recall, it was in red, which means we should never use it. Why? Because the precision of a float is just really bad. The problem is that double floating point values on a digital computer cannot be exactly represented. So just as an example, if I have 2, let's say 2, and I divide by 2, and I want to test whether that is equal to 1, this may be false. This can actually come up to be false. Now, for this particular one, it may be true, but if I use slightly different values, then it could be, in other words, if I compute a double value one way and compute it another way, I may get completely different representations in the computer. So these 128 bits that are representing that floating point, if there's one bit that's different, it could be like in the 16th decimal place. If that's different, then this is going to come up to be false. That's why we don't use it for doubles. Okay, not equal is not. And then finally, if you know, we can use these two operators on objects as well. Typically, we don't want to do that.
I had a question for that example, the 2.0 over 2. Can you use like a double divided by an integer, or do they both have to be of the same type?
Great question. The answer is yes. What happens with this is something that, okay, I was planning on talking about that later a little bit later, but we'll talk about it now. What it does with primitives is this, is that it will, if I have an expression that involves both integers and doubles, then it will promote any of the integers into doubles before it does the computation. In other words, if I do this, then it will allow this, and it will basically take this 2 and turn it into from an int 2 into a double 2. Now, this is kind of a legacy thing, and to be honest, I think that this is something that they shouldn't allow, but they do. And it's kind of at the margins. If you're really being strictly typed, strongly typed, then it shouldn't be allowed. But in practice, it actually is. So and I'll come back to this, and we'll kind of talk about expressions and how this kind of works. But just briefly, if I have an expression that involves integers and doubles, then the answer is going to be a double.
Sir, just a question for,
Sure.
So for the equal operator, is that the only one? So can you use like the greater than or less than equal to compare doubles?
Oh, yes, absolutely. Yes.
Okay, it's just the equals one that you.
Yeah, what it is it's dangerous because I could have two values. And again, I think for this particular one, I haven't tested it, but there are examples. If I have two expressions that should be the same value as a floating point, but are only approximated because of the fact that it's a digital computer and I can't represent infinite precision, If there's any difference, then this double equal will fail. What you should do in a case like that, if I'm comparing doubles, then what I want is I want a level of precision, some kind of epsilon that says if I have two doubles that are different by no more than 10, 2 to the minus 10 to 10 to the minus 10 or something like that, then I'll consider them to be equal. And what that involves is kind of taking the absolute value of the difference and seeing whether or not it's less than or equal to this other precision that I'm doing. That's the way that's the way you need to be kind of made ironclad against that. Okay, string operators. This is concatenation. Yeah, you've probably seen this before in JavaScript. Okay. In Java, and I still kind of use that because of laziness, but actually the string class in Java, strings are first class objects. They're built into the Java, and they have methods that allow you to do that. So in other words, instead of using plus, it's actually better form to use a method called concat, which concatenates it. But there are other things I can do with strings. I can replace characters. I can, instead of saying two strings are equal, I want to use, you always want to use the equals method. In other words, if I have two strings that have the same characters, then for my purposes, they're the same strings, but those two strings could be different objects. And the double equal when it comes to objects, this says whether they're the same object. And I can have two strings that have exactly the same characters, but are two different objects. And so, but the equals method will come back true even if they're different objects. And in fact, this is sometimes very convenient, that if I have two strings that are the same except case, one might have a capital and where the other has a lowercase, equals ignore case will come back true if they have the same letters, regardless of case. We're going to go into that later in the course because string manipulation can be very important. Okay, do I have, yes, okay. I only have enough time for one of these, but I will do the other when we pick up on Monday. So, okay, let's sort of keep that for now. Yeah, the equals ignore case is very, very convenient. So, and we're going to spend some time working with strings later in the course, but that's just kind of a preview of coming attractions. All right, so I wanted to go over this here. Okay. Okay, and I'm going to do something that I'm typically not going to allow you to do, but I'm going to put a main class and a component in one just because I'm running out of time here. So okay, so this is an example of an encapsulation breach. All right, so okay. What do you do? Oops. Let's do it down here. Okay, so here I'm gonna kind of cheat a little bit. So here's a class, and I have an instance variable that's going to be an array of strings. Okay, and now if you remember this refactor encapsulate fields, I'm going to have a setter and a getter for this. And let's put it after, let's kind of put it at the bottom there. Okay. Fairly straightforward. Now, here, here's a short, this is kind of a shortcut way of creating a string, an array. Okay, so here I'm in main, and I'm creating an array of strings, and there's a well, that's what it is. All right, so now okay, so now I'm instantiating one of these guys. And what I'm doing is now I've set it, and now I want to see what is in there. And so I do that with a print line. Oops. And so when I run that, what do I get? I get the default toString, which is not very informative. So instead, I write one of these toString guys, and an override. Okay, so now when I run it, see, so now when I print the object, I see what I got there. So everything seems to be fine, right? So here's what I did. This setter says, okay, if I set the array of names, then it simply sets it. And this is what this is the getter and the setter that get generated by NetBeans. So that's fine and good. Everything seems to be perfectly okay. And okay, so now I've taken this array, I've passed it in as an instance variable. So now it's the names in this. And now I want to do something else with the array that I passed in. So I say, okay, I want to change the third argument, the third element. All right, no, not a big deal, but now okay, so look what I've done. I've taken this local variable, this local array that I use just to try to pass the data into this instance. All right, I passed it in. It got there fine, no problem. And now I say, well, now I want to do something else with this array. So I want to just change this last value here. So the fact that I've changed this local array shouldn't worry me, but watch what happens. Look at what happened to the instance variable inside my object. When I changed this guy out here, it changed the guy inside. Do you see that? That's a breach of encapsulation. In other words, this object should protect my variables here. And the only way that you should be able to change it is by this setter method. And that's fine. But that's not what I did here. I didn't invoke the setter method. I just took my local variable here and I changed the value. And all of a sudden, the instance variable in here got changed. That's an encapsulation breach. In other words, this class has not protected its data. So what's the solution? The solution is a method that all arrays have, and that's called clone. So now, when I set the names, what this does is this says, okay, I'm going to take this array, but before I set it to my instance variables, I'm going to clone it. Meaning, and what does clone do? It just makes a new array and copies all the values in it. And when I do that, now, instead of this, see now, even though I've changed my local guy, it hasn't affected the object. In other words, now my data are protected, they're encapsulated well. But that's only half the story. Here's the other half. I have this getter method. Okay. Darn. Okay, all I've done here is I've used the getter to get the to get this. See, here's the getter. And now I say, okay, all right, I've gotten these names, but now I want to change my value of these to Joe. And what's that done? Now all of a sudden, again, this is a second encapsulation breach. What's the solution? Same solution as before. If somebody wants to get it, they don't get my array, they get a copy of it. And so when I give them a clone, now, even though I've changed my local variable, it hasn't changed that. And I see I've misspelled Groucho. Okay, so that's what I mean by an encapsulation breach. And this is something to watch out for because this can bite you. This can bite you real bad. Okay, so when you're using arrays, you need to make sure you always return a copy, a clone. And when you're setting arrays, you want to make sure you always set a copy, a clone. Okay, so now, before I let you go, just a question. Has everybody been able to pull my code that I pushed from the class? Has anybody had trouble with that?
I just received it when I reopened my NetBeans this morning. So.
Yeah, it shouldn't, like now, whenever after a class like this, I've added some code to this. Now, shortly after the class, I will push it and you'll have to do a pull to download it. It won't update. GitLab will never update your local repository automatically. It never does that. You have to explicitly do that. Okay, so I have not committed this yet, but I will shortly after that. And what I try to do is I try to add comments because commenting code is something which is very important and something I will require as well. But just for the purposes of illustration, I don't do it in front of you here. Okay, so you know, mull around this example and make sure you can kind of wrap your heads around what was going on with that, because it may have gone by fairly quickly for that. Again, I'll push the code. You can kind of see it and play with it yourself, and I will address any such things. Okay, the next thing, tomorrow morning, bright and early at from 8 to 8:15, there's going to be an online Sakai quiz. It will be very short. It will be very easy, I promise. And then after that, I will have something I'm going to kind of torture you with. Tomorrow's lab, and typically what I'm going to do with the labs is the labs will be a programming assignment that you should be able to finish either in the course of the lab time or at least by the end of that day. So tomorrow's lab assignment will be due by close of business tomorrow. And then on Monday, there's going to be a follow-up to that that's going to be due a little later in the week. So again, like I've been doing all the work so far. So far, all you've done is Hello World, but that's about to change. Okay, so I will see you tomorrow if there's nothing more. Thank you for your indulgence and the extra time.
Thanks, sure.